record the session. All right. So I believe recording. Yeah, good. All right. So let me start with first giving you a high-level overview of Cisco certifications. And Cisco is like one of the leading vendor in networking, and Cisco, Juniper, Checkpoint, Palo Alto, a lot of vendors in like IT and network and security domain. Cisco is the big name, obviously, undoubtedly. Cisco is very big name, and mainly in computer networking, data center technologies, and there are different levels of training and certifications offered by Cisco. So Cisco recommends one should start like training from this entry level. Then the next level is associate level, third one professional, and the fourth one is expert level. So there are 4 different levels of Cisco trainings and as well as certifications. Entry level is not mandatory. I mean, like you can directly jump to this, the next level, that is associate level, level 2, because entry is all about networking basics, and very much we are going to talk about networking basics in this associate level training, that is CCNA. So no need to start from this entry level. You can directly start from associate level training because associate level is your CCNA, Cisco Certified Network Associate. I'm going to talk much more about this CCNA certification. So this entry level means like networking basics. If I move to the next level, that is associate level training like CCNA. And if you would be interested in certification also, I mean like writing online exam for the CCNA and then obtaining a certificate from Cisco. So for that, you'll have to pay 300 USD directly to Cisco. And there is provision to take this certification exam online or maybe in person. Even you can visit authorized test center to write the exam. If you want to take exam from comfort of your home, sitting at your home, then that is also possible. After paying this amount, 300 USD, you can attempt CCNA certification exam. And exams means like objective questions, like no lab involved here in CCNA, just like questions and then multiple options, and probably 1 or 2 options would be correct in fact. So that's the way how your knowledge is judged by Cisco. And once you like clear that exam, online exam, CCNA exam, then you will be given a certificate from Cisco, that is Cisco Certified Networking Associate, right? And certificate is valid for 3 years in general. So after 3 years, you'll have to recertify like the same CCNA. But certification is like obviously not my objective only that you should be certified only. My objective would be like just giving you good knowledge. And because if you know like basics, you know like configuration, troubleshooting, network setup, so certification is not a big deal. It's just matter of doing some practice of like expected question answers, doing some simulation, and then straight away you can write exam of CCNA. Similarly, if you want to go to the next level, I mean like once you have completed your second level, because first level, as I mentioned, first level is not mandatory, that you should start from like entry level certification, so you can skip this entry level, right? I'm sorry, this pen is not working. Let me just, oops, just giving, no worries. Okay, so let's say you have like started from second level, like associate level means CCNA, the training that I'm going to start. Entry level, as I mentioned, not mandatory, optional. So it's only about networking basics, fundamentals. And very much I'm going to cover those like stuff, networking fundamentals in this CCNA also. So the next level is professional level. And name of certification and training program is CCNP, Cisco Certified Networking Professional. Again, like only written exam of approximately, I believe, 450 USD plus applicable tax in your country. And then the last one, something pops up in between. Okay. And the last certification is CCIE, Cisco Certified Inter Network Expert, right? And very competitive exam, tough. In fact, it's not very easy because in order to get CCIE certification, there are like two steps. In fact, first step is passing out written exam, online exam, and then hands-on, like the lab exam of 8 hours. And exam is also very expensive. This will cost you somewhere around, I believe 1600 USD is the lab exam, 450, somewhere around like 2100 to 2300 USD per attempt. And lab, you understand, like you will be given a whole bunch of Cisco devices. You will be asked to configure those devices. Worldwide, there are approximately 60 to 70,000 engineers who own who are CCIE certified, the most prestigious certificate given by Cisco, CCIE, right? And why most prestigious? Because of this lab. In fact, you'll have to go to Cisco like office. In fact, in person. I mean, like there is no way to take this exam online. You'll have to visit the Cisco center in your country, in your location, and then after fee submission, after booking your slot for the exam, then you just take the exam. And very typical, very complex, and I never recommend anyone like just attempting CCIE exam without 2 to 3 years of hands-on or prior experience, right? So once like you finish the CCNA, like associate level training, and if you are interested to get this certification done, you want to take this CCNA certification. So CCNA exam fees is just 300 USD, only written exam, no lab, objective questions, 120 minutes. So very easily you can write CCNA exam, you can pass the exam in first attempt, right? Because we are going to cover like all the topics, all the like complete knowledge I will try to give you for the CCNA, at least in this training. And then maybe probably like you can just go to the next or maybe the next. So this way, like CCNA certifications and training are like provided by Cisco, and Cisco is the vendor. Cisco is one of the leading vendor. The company name is Cisco Systems. These training certifications offered by Cisco. And if quickly I show you my certificate, I'm also CCIE certified, right? So I have reached to this point, the last certification, that is CCIE in enterprise infrastructure or networking. So once you clear the exam, then you get the certificate very similar to, let me quickly show you. Here is the certificate. It's my certificate, right? CCIE, Cisco Certified Internet Network Expert. And a unique number is also given, and you can see like it's online lab exam report. And I completed this exam in 2014 in India itself, in the Bangalore, and it's my CCIE number 43923. It's a unique number. You are given a unique number. Similarly, if you do some other exams like professional level, then you get certificate very similar to this Cisco certified specialist. And even in this CCIE, you get a proper medal, kind of like, like shield, in fact, and a lot of other stuff also Cisco provides. So very valuable, no doubt. Cisco certifications are very valuable. And even if you want to start your network career journey, maybe security engineer, cloud expert, right? So strongly recommended that you should first start with CCNA. CCNA is the first step in like networking, network security. Cyber security is another very good field, very much in demand. And the same like cloud is also obviously is very much in demand, like Microsoft Azure Cloud, Google Cloud, AWS Cloud. So cloud networks are very popular nowadays. Cyber security, maybe network security, networking itself. So a lot of different domains nowadays. But prerequisite is CCNA, because in CCNA we are going to understand the whole concept of networking, a bit of security, network security. I mean, also your network devices, routers, switches, firewalls, like whole bunch of networking devices we are going to cover here, protocols, right? And once like you understand networking in depth, so then you can understand any technology, data center, cybersecurity, cloud, or any other domain, right? So it's strongly recommended that one should always start from CCN. And here is the like official page of Cisco certifications and associate level, this one. So we are starting with this CCNA. In CCNA, there's only one exam, right? Core exam, 300 USD, the exam fee, and certifications are valid for 3 years. So CCNA certificate valid for 3 years. And then after, recertification would be required. Recertification, again, paying the same amount, like 300 USD, writing exam for that. And even on its official website, you can see as so there is no formal prerequisites, but 1 or more years of experience implementing and administering Cisco solutions is recommended. So it's not mandatory that you should first take entry level certification and training and then like jumping onto this CCNA. You can directly go to this, provided you should have some basic understanding, basic knowledge, and we are going to cover that. Is the exam code, in fact, 200-301 that we will be covering in this training, 200-301. What all topics we are going to cover in this training? So network fundamentals, I will start from networking basics, network access, IP connectivity, IP services, security fundamentals, and a bit of just high level overview of automation and probability. So there are different sections here, and it's 120-minute exam, right? If if you want to take the exam, and you'll have to book this exam online, and or in person. If you want to write the exam in person, then Pearson VUE is the partner like authorized testing center. So you can search for this Pearson VUE testing center in your locality, in your nearby, and then you can visit that center. You can get your exam booked, and this way like for one and it's just objective computer-based test and objective only. As there is no lab involved here, maybe a couple of simulation kind of thing, but as no 8 hours or 10 hours labs. Lab is only in CCIE, right? The CCIE certification. All right, so moving on from here. So if any question related to like Cisco certifications, maybe if you are curious about the certification, the way how we are going to proceed. So yes, you can ask your question. You can, if you have any query, if you have any doubt in your mind, so yes, go ahead. You can ask here. Yes, I'm going to start with first networking fundamentals, networking basics. I assume that you are very new to this networking field. You all know computers, internet, other stuff very well. But networking, network protocols, networking devices, routing, switching, firewalls, all are very new to you guys. So assume that I am going to start from very beginning, basics, I mean fundamentals. right? So that we all should be on the same page. So quickly, let me open. And another important thing, since I'm conducting this training online, so and in this CCNA training, a lot of lab exercises would be required. So for lab exercises, you have like plenty of options. Like there are a lot of simulators. You can use those simulators for building your home lab setup. You can start doing your lab, and I will also guide you how to use those simulators. Like the one that is very popular, strongly recommended by Cisco is Packet Tracer. Is one of the simulator. You can use this. Maybe GNS3 is another software or simulator. The third one is EVNG. So you can use any simulator for building home lab, for doing your lab practice. And almost 90 to 95% labs you can simulate in in virtualized environment on your laptop, on your desktop. I'm going to help you. Also, I'm going to guide you like how to build that. But yes, like that is possible. You can easily build a home lab, like the packet tracer. I believe I have one here. This kind of simulator. So here we get like a whole bunch of devices. I mean, like routers, switches, everything. So we can use like a simulator this way. PC or maybe servers, laptops. So we can do like a whole bunch of like networking exercises, security related exercises. There are some other tools also. I'll guide you like how to use this Cisco packet tracer for building lab and doing like lab exercises. All right, so moving on from here, and I'm jumping on to the very first slide, right? And I forget to introduce myself. So my name is Manos Verma, and I've been into this networking field for more than 20 years now. And I teach Cisco technologies like CCNA, CCNP, CCIE, a lot of F5 products, cloud also, cyber security, network firewalls like FortiGate, Palo Alto, Checkpoint, and I hold like 6 to 7 different certifications, right? And that's it. All right. Okay. So I hope you all can see my screen, right? I think I've shared my screen. Yeah.
Yes.
Oh, good. All right. Okay. So starting with like computer networking first. So computer networking refers to interconnected networking devices or computing devices that can exchange data and share resources with each other, right? And that's the basic purpose of like networking, be that your like local area network or network within the same building, within the same premises, or maybe wide area network. The purpose is sharing resources, right? And also another important point to understand in networking is protocol. So I'm going to talk about protocol also later on. Very important, right? Protocol, but later on I'm going to talk about like different protocols here. So in general, networking means sharing resources, right? Sharing resources. And resources can be a file, maybe a folder like the file sharing. So we need a network so that users can reach a shared network drive with documents, pictures, or other files. For example, if like maybe here, a computer here, a machine in fact, and a large number of files and folders are saved onto this computer, maybe on the local disk, and other computers, they also want to access the like files or folders stored or kept here on the machine, on the server. Generally, we use a term file server, right? So yes, like networking is need to be done here. So if computers are on the common segment on the network, so very much like computers can access files or folders or pictures or any documents is stored or saved on a specific machine, a server, or a file server. We also use network for sharing information, like email, for example, or to reach certain websites. That's another use case of networking, like information or maybe file sharing, resource sharing, like printers or some other resources, in fact. So another use case, we can connect a printer to the network that is used by multiple users. No need to connect a printer directly to each computer. So if there are 20, 30, 40, or 50 computers, there's only one printer and they all want to access, they all want to use the same printer. So yes, networking can solve the problem. So if there is networking, computer networking, so no matter like whether a single printer or multiple printers, they all can access, they all can use the same printer if like there is networking. Similarly, we can also use networking to share applications. So maybe on one computer, if application software is installed and other machines, they all want to access the application installed on a specific computer. So yes, networking is going to provide that also. Maybe like application is very heavy application and computers like do not have much resources, like no sufficient memory, disk space, maybe compute power, right? So we cannot install application softwares on all computers. Application software is installed on only one machine, and we want that computers, like they should also access or run application installed on a single computer or machine. That is also possible if like there is networking. So there can be like a lot of use cases. I mean, like the wherein network is going to solve the problem. Either resource sharing, application sharing, file sharing, information sharing, right? So we use networking. So network means like resource sharing, and resource can be files, folders, printer, even internet connection. Let's say in your small office, home office, or maybe let me open a blank screen here. Okay. So let's say there is a internet connection. You have internet and terminated on directly maybe on a PC, laptop, or server, or maybe another device. And I'm going to use this term very often, like router, and I'm going to talk about this router as well later on. So if internet is terminated on a single device, and let's say there are 4 or 5 computers or laptops, they also want to use the same internet connection, then again, networking, either like wireless, wired, any type of network, yes, with that, we can provide internet access to other computers. So we don't have to buy, we don't have to take multiple internet connection. A single internet connection can be shared by laptop users, desktop user, like other users, in fact. So it's another use case. I mean, I'm sure like you all know very well, like the networking and the network uses, like the use cases. So let me quickly jump to the next point because it's very basic, and I'm sure like you all using internet and laptop, desktop, tab, and other stuff. So you all are very much acquainted with networking as in general. I mean, like what is networking? So nowadays, when we talk about networking, so there are 3 different types. One, local area network. The first one is local area network, or LAN. Next, wide area network. And the third nowadays, even service provider network. And the last one is cloud network. That is also very popular nowadays. LAN, I believe, anyone would like to explain these 3? Local, wide area network, or service provider. Any idea, any knowledge about LAN, WAN, service provider, or cloud networks?
LAN is specific to your office or home. And
okay.
WAN is wide area. I mean, to different building or to like and long distance, and that too. And the service provider network is also, as you mentioned, and is Azure or cloud.
Okay. Okay. So as you mentioned, like local area networking, LAN is something like a network that we set up in our home, like the home network, or maybe in the same building or same premises or a small office, home office, any type of network. I mean, like wherein resources are placed in the same location or in the same premises. And WAN, as you mentioned, is something like wide network. I mean, like if one network is in location A, another network maybe location B, and if we are somehow, if we are ensuring that they both should access resources of each other, they both should share information with each other, and we are setting up some like networking. I mean, like network A is in city A or country A, network B is in country B or city B, and then with the help of internet or maybe some other carrier, some other transport, if we are setting up networking, then that's what like wide area network is, right? And yes, that's true. But further, I'm going to add some few more points to both like LAN and WAN. And as you mentioned, service provider network, yes, it's very much like internal networking of any service provider, like your AT&T, Verizon, or Sprint, or any other like service provider network, right? It's very complex, in fact, and because generally they use very higher-end networking devices, very good in like compute power, resource handling, right? So service provider networks means very robust networking devices, appliances, and using some latest technology because they facilitate or they ensure that different networks using their services should freely talk to each other with minimum latency, right? So that's something very different architecture, and there is some specialized training for that also, like understanding service provider network, how service provider network is built, what all equipments and technologies are used to build like service provider network. So it's very much like out of a scope in this training session. So mainly we would be focusing on LAN and as well as wide area network in this CCNA training program. LAN and WAN, yes, very much. We are going to cover both. Service provider network, yes, like we will talk about service provider network, but not in very detail. I mean, like because there are a lot of core technologies they use, like MPLS. If you, I'm not sure, like whether you have heard or not, but maybe MPLS or some other packet switching and higher-end routers, QS, and then I mean, like some advanced technologies for now you should understand. So we would mainly focus on these two, like local area network and wide area network. So let me give you a very quick overview of both. So if you have like a small office or maybe a home or your enterprise network, and here like you have the computers, I mean like the laptops, desktops, servers also, right? And a lot of network devices here. I'm going to talk about those devices as well, like network switches or maybe Wi-Fi routers or IP phones, etc. Different network devices, but in the same building, in the same premises, right? In the same building. And we are doing like, we are putting all together. I mean, like we are doing cabling, we are connecting them together so that they can share resources with each other. But yes, like access is very much limited to the same building, to the same premises, to the same location, in fact. So in the same building itself, like one computer is here, maybe on the first floor, second computer, maybe ground floor. The next one is maybe maybe even to adjacent building. So still we can set up local area network, right? And because nowadays we use optical fiber cable. So optical fiber cable means like very much we can connect different buildings, different networks all together, even if they are 1,000 or 100 miles away from each other. So yes, even that is also possible. We can do like connectivity all together, because optical fiber cable means like a long run cable, in fact, and I will explain that also later on, not the right time to discuss everything. So in general, LAN means like a network within the building and within the same premises. And if there is another network, LAN 2 maybe, in different city, different location, here again, like whole bunch of networking devices. Now we want that these two different networks, like LAN, a local area network 1, in maybe a city A or country A even, right? Or state A, and LAN 2 is in different state, different city, or different country even. And if we want that they both should like share information, exchange data, right, with each other. And at somehow, if we are setting up networking between these two remote networks, either using internet as the transport, or maybe some other way, in fact, apart from internet, even like very much we can do like point-to-point connectivity between these two networks. And I will talk about like that point-to-point networking later on. So that can also be possible. And there are some other technologies also, WAN technologies. But again, in order to connect these two remote networks, we will have to take like services offered by internet service providers. So we'll have to bring in here like ISPs, in fact, AT&T, Verizon, or some other internet service provider. They can facilitate connectivity. Even in case if we need internet, then again, we'll have to approach service provider. Or maybe for point-to-point connectivity, again, a service provider. So service provider service would be needed here, plus other configuration that we will be doing at in both the like LAN 1 and LAN 2, like putting maybe a device like mainly used for providing this kind of networking or doing networking, like technically it is a router, like routing traffic between different networks. But this is a bit complex, obviously, right? It's a WAN part, wide area network part, connecting different networks. And not only two, even there can be more than two networks, 20 networks, 30 networks in different countries across the globe, in fact, anywhere. Yes, with the help of wide area network, we can ensure that data is exchanged, information is exchanged, file is shared. We can do that either using internet as a transport, or maybe without internet even without internet also possible. There are multiple ways. There are a lot of WAN or wide area network technologies. So why is so important? Specifically, why I'm talking about LAN or WAN? Because this way or that way, both are like doing the same job. I mean, like whether LAN, local area network, or wide area network, they both are meant for what? For resource sharing, file sharing, folder sharing, information sharing, accessing a website or web server, data transfer. Yes, but equipment, network devices, protocols, technologies that we use in LAN are very much different than the wide area network, WAN. So WAN technologies are different than the LAN. And that is why specifically we use these two terms, LAN and WAN, local area network and wide area network, because they both are like networks. But since different protocols, different networking devices, equipments, and even like in wide area network, we would have to take help or services offered by service provider. So service provider will come into picture. In LAN environment, no need of taking any like lease circuit or internet circuit or P2P circuit from any service provider. You can set up at your own. You don't need involvement of third like organization or companies or provider. But in wide area network, yes, because you understand, like if you are in maybe in New York and maybe another location in LA, and you want to do networking, even in case if you want to use internet as a transport, so you'll have to approach internet service provider for internet connection at least, right? And maybe some other stuff. I mean, like some like dedicated services offered by these service provider. I'll talk about those services later on. But at least, yes, there is dependency. You'll have to take this, or even if you want that these two locations should be connected point to point, I mean, like without internet, private lease circuit, right? Because as we know, like internet is not very safe place. Public network, billion of users are connected with the internet. Networking of network is what we call like internet, in fact. So if you prefer not to use internet for wide area network, so yes, that is also possible. You can ask your local service provider, internet service provider, for a private lease circuit, right? Obviously, they are not going to take they're not going to put wire at the same time. Already cabling already done by the service provider, like underground optical fiber cables, right? So what they would be doing, they would be providing a pair of cable maybe on lease, right? You will be paying rent to the service provider. They would make this communication happen. They would like provide physical reachability, because as a customer we cannot do that. We cannot do cabling. I mean, like we cannot connect these two locations, right? With optical fiber cable, because that's not our job, in fact. So cabling already done. We just take cable or optical fiber media on lease from the service provider, and then we just complete the networking. And that's why, like specifically, we discuss these two terms altogether, LAN and WAN, because WAN means like different technologies, different set of equipments. And in LAN, no, we don't do anything, right? So let me jump to this presentation file. So LAN is a collection of devices connected together in one physical location, such as building, office, or home. A LAN can be small or large, ranging from a home network with one user to an enterprise network with thousands of users and devices in an office or a school. That's all like termed as local area network. And in LAN, in fact, we use access points like for Wi-Fi network, and cables for wired network, right? Because nowadays, like wireless networking is very popular, very common. Even a small office, home users, very much they prefer wireless networking, right? Because wireless means no wire is just going here and there. However, wired network is better if I compare wireless networking with wired networking, wherein like we use cables to connect the devices, media, communication media. So yes, wired networking is better than wireless, very fast. Nowadays, we can have a wired network of 10 gig, even 40 gig, even 100 gig, in fact, not possible in wireless networking. But for home user, small office, home office, right, wherein a speed like of 10 gig or 40 gig never desirable, right? So yes, wireless is the best option because the cable is not running everywhere, in fact, like in this wireless. And why do you understand like cable and some other devices? So access points means like used in wireless networking, cables in wired networking, switches. Yes, like switches. I'm going to talk about this switch device also later on, but it's another network device used in local area network. And because if let me if you are not very much aware of this device, so let me talk about this also. Let's say you have two laptops or desktop and you want to connect both laptops and desktop. I'm talking about wired networking, wired. So if there are two laptops or desktop, so yes, like with a cable, also known as this cable is UTP cable, or we use the term patch card. and how it looks. I'm sure you must have seen this cable. Otherwise, I'm going to show you that also. So generally what we do, we take a patch card, a UTP cable, and we connect both laptops or desktop this way, point-to-point connectivity, I mean, right? Point-to-point connectivity, because generally laptops come with a Wi-Fi adapter, wireless adapter. Even desktop computers also, you find a network adapter card, right? So what we do generally, we insert one end of cable here, like laptop or desktop, another end here. That's it. Now very much like they both can now share resources with each other. Networking, physical connectivity, yes, done. But what if you have more than two computers? Let's say you have 5 computers, 5 laptops, and you want to connect them like all 5 computers. So connecting this way, not possible. You cannot connect 2 computers directly, right? So there we then put a centralized device known as a switch, network switch, right? And there are different ports here on the switch, a hub kind of thing, a centralized point, and devices like computers and host devices, like connectivity goes this way. So computers not connected directly with each other, rather they all would be connected to this centralized device switch. So this switch, network switch or device, yes, required if there are more than 2 host devices. You want to connect more than 2 devices, then definitely you need a centralized device, network device, right? And if a switch has total 8 ports, so maximum you can connect 8 devices. If switch has 16 ports, so you can connect 16 devices. 24, then 24 devices. Even you can connect another switch with this switch, right? For expansion. So let's say you have office at ground floor, first floor, second floor, and you want to put one switch at each floor. Yes, that is possible. With the cable, a switch can be connected with another switch. So this way we can extend local area network, right? And how much distance we can travel, I mean, like how much distance supported by this cable, again it depends. If we are using a traditional copper cable, copper, right, unshielded twisted pair cable or copper cable, then maximum distance supported is just 100 meter only, right? So what if my under building maybe floor is very far, I mean like 500 meter, maybe 1 mile away from each other, or maybe 2 kilometer. So yes, this cable cannot be used then we go with optical fiber cable, at least connecting these 2 switches, right? So longer distance, longer run, then different media, different cable. Shorter distance, yes, we can use copper cable. They're different approach. But switch in general is a centralized device wherein all end devices, host computers, they all the connection get terminated, right? So this device facilitate like communication within the network, a centralized device. And when we order for a switch, when we purchase switch, so generally we also make our selection whether we want 8-port switch, 16 ports, 24 ports, 48 ports, and even the maximum data transfer rate, how much speed, how much data transfer bandwidth supported here, 1 gig, 10 gig, 40 gig. And nowadays, even like there are switches supporting 100 gig, even like in Cisco also. And Cisco is one of the leading vendor in switches. There are a lot of other vendors also. So switch, yes, is a network device used in local area network, access point for wireless cables, as I mentioned, cable, yes. Router is another device, and the router is mainly used when we have to connect different networks, right? I'm sorry. different networks. Again, it's a network device. Router is a network device. And let's say you have like 3 or 4 computers, they are connected with a switch. It's a centralized point switch. Now, you want to have internet access on all computers. So for that, a device, like a router device, yes, would be needed here, would be required. Why? Because internet means again what? Internet is another network, and this is my home network or a small office, home office network. So router is sitting in the middle of communication stream to facilitate intercommunication, right? Communicating with different networks, because internet again is what? A different network. Internet means network of networks, rather I would say network of networks. So yes, a router, a network device required here, needed here. So router facilitate communication across different network. So generally, I mean, like there are a lot of other use cases. So it's very high level overview I'm giving you, right? Very high level overview. I will get deeper inside it later on. Just I'm introducing all these terms like to you guys so that we all should be on the same page. Otherwise, yes, router is used for a lot of other regions, a lot of other purposes. Wireless router, enterprise routers, service provider routers, routing across different networks, maybe in the same building even. Sometimes what happens, we use this device in LAN also nowadays, right? And I'll take one couple of use cases to justify this point. Why do we use a router in the LAN? In fact, I mean like LAN. I mean like not typically. I would say LAN means in the same building. If there are different networks, yes, router would be required there. But in general, router means routing traffic across different networks, between different networks, like your network and internet. So router is sitting in the middle of communication stream. So router is another device, and yes, like WAN, in WAN also, like we use router, in LAN also we use router, because router has a lot of use cases. And so in WAN also, like we use this. And another network is WAN, so enterprise network, spanning buildings, cities, and even countries, is called a wide area network. While local area networks are used to transmit data at high speeds, within close proximity, WANs are set up for long distance communication that is secure and dependable. Secure, again, there is a question mark here, whether wide area network will be secure by itself, or we would have to make that connection secure. That depends again what type of WAN connection we have. If connectivity is done using internet, via internet, right? So internet itself is not secure. I'm sure you are very much aware with the fact that internet is what? A public network. Internet means a public network. It's not a private network. Network used by anyone. There is no restriction as such. Public network. So if my one network is here, maybe one network is in India, another network in US East region or US West region, and I want to like set up connection between both remote networks, network in India and in US. Here also like a whole bunch of like network devices, servers, computers, here also computers, servers, right? And my objective is to access resources of this US East region from here to here. And if I'm going to use internet as a transport, means internet I'm going to use as a WAN transport. So internet is not secure, right? So if data is moving this way, going to this internet, so internet is what? Internet is network of networks. Network of networks. networking of different networks like Cisco, Amazon, Netflix, like they all are interconnected. So whole bunch of like networking devices connected with each other. So the packet, maybe important file, a confidential data is passing through various networks, different networking devices, right? So you understand, like if the data is sent in the clear text, plain text, no cipher data, plain text, readable, human readable. So you understand, like anyone who is connected to internet, who has some coding knowledge, some hackers or attackers. So yes, they can read the content, what type of data I'm sending, what kind of data I'm receiving, maybe the confidential data, username, password, social security identifier number, credit card information, anything. So it's very much like vulnerable. So generally what happens when we use internet as a WAN transport, then we add extra layer of security. We as an administrator, we as a network engineer, Cisco guys, like what we do, we ensure some like encryption or maybe ciphertext, at least the data payload, the data that is just passing through the internet should be ciphertext, non-readable, scrambled, right? So even if anyone, like any attacker, like connected with the internet, and somehow if he manages to get the packet, to get the data, so at least the guys will not be able to read the data, so not be able to do the decryption. So we do all this, right? Because we understand, like public network, internet is not a secure place, not a secure network. We cannot afford to send data in the clear text using internet as a transport. But internet is easy, internet is cheap, internet is very least expensive solution. So a lot of companies, they prefer to use internet as the transport because of availability, because of the pricing. But on the other hand, not a safe place, not a secure way. So we generally, if you have heard the term like VPN and other stuff, virtual private network. So basically we do all this like IPsec VPN, SSL VPN, and all that stuff just to make this communication secure. Or if we don't want to go this way, we don't want to use this internet and all that. So, and the solution is what? We can approach any service provider, right? Maybe in India region or US region. We can approach any service provider and any internet service provider, and we can ask internet service provider to provide international private lease circuit. International, right? Because different countries now, example is of different countries. One network is in India and is in Asia. So India is in Asia and US is in America, right? Different countries, different continent. So I can ask the service provider to provide international private leased circuit of maybe 1 gig of data transfer rate is something like a private link. Means this network is directly connected with the US region. But how does it happen? I mean, like whether service provider will run a cable from India to US for me only, for this company? No. Already they have done a lot of networking, right? Different countries, they all are very much connected with optical fiber cable, submarine cable, underground cable going through this ocean, sea, right? In water, in fact. So already cabling, yes, already done, in fact. And you must have heard like news sometime like internet service disrupted for a couple of hours because maybe a fish or something like broken optical fiber cable. So yes, sometime even though they are doing a lot of maintenance work and all that, and there is association of like a lot of service provider. So responsibility is not in single hand. So a lot of like it's a community responsibility. I mean, like a lot of service provider are doing their job, and also they are making good amount of money from that. So already cabling is done, cable has been laid down, right? Optical fiber cable. So what we are doing basically from the service provider, we are taking a pair, a single pair, or maybe a single cable on lease, and whole bunch of cables already put on like here. So if this way we connect two different networks, it's again a wide area network. One network is in India, another network is US East, or maybe in the same country, different cities, right? Same country, different cities. So generally we use the term NLD, National Long Distance Link. Is different link, right? Pricing would be less as compared to IPLC. Why? Because if my network two different networks are in the same country but in different cities, in different state, then obviously like pricing would be much lower. So it's another way of doing a wide area network or connecting different networks, and a secure way, right? Because it's a dedicated connection. You are connecting these two networks with a private circuit. I mean, like with the private dedicated cable, right? Not data is not shared here. Media is not shared by anyone. No one else, like no one, like other companies' data is not getting or being transmitted via the same media. Very secure, but very expensive, and it is always subjected to the feasibility whether service provider has agreed to provide this connection, in which city, in which country your network is situated, whether there is any presence of the service provider. So it's always subjected to the feasibility, right? What about internet? Internet is everywhere nowadays. In any like wherever you are just putting on, in which part, in which state, country, no problem, right? Everywhere, internet is everywhere, and just call the guy, and maybe in next couple of hours engineer will be at your place, in fact, right? And you would have internet in just maybe within a day, in fact. And it's a lengthy process. It takes a month, a couple of months, in fact, for provisioning, licensing, installing, configuring, a lot of stuff. But yes, this is also possible. So WAN is again like like different ways. Generally, as a beginner, let's say if I'm starting my career as a network engineer, so generally what I think, I generally I would think that okay, my network is in, let's say, India, and the network maybe in US East or African country, or maybe in different country of the Asia region itself. So generally what we think that the internet would be the only way to connect these networks. No, that's not true, right? Even we can connect different networks without internet, without internet. And that's what private leased circuit is, private connection is. I'll talk about this WAN technology later on. But for now, I hope you all understand WAN means connecting different networks, maybe in different cities, in different countries, in different states, is what wide area network is. Generally, wide area network data transfer rate is slower, obviously, because of distance and the equipment devices that we use. Whereas local area network, your LAN, a network within a building or within the premises, very fast, right? So that's another difference, in fact. I mentioned about service provider networks. So service provider networks allow customers to lease network capacity and functionality from the provider. So it's the network inside the service provider. Network service provider may consist of telecommunication companies, data carriers, wireless communication providers. Generally, we refer service provider in networking mainly ISPs, internet service provider. And why service provider network is vital, important to know or to understand at maybe when we just move to the next level in networking. So because like they use very similar like router switches, but power, compute power, processing power, capacity, data transfer rate would be much more higher than the devices that we use in our enterprise network. And a lot of other different technologies, right? Technology that we use in our network, enterprise network, and service provider technologies are a bit different, in fact. And that is why sometimes become important to understand. service provider networks also, but at least in CCNA, not very much relevant in fact. But yes, I will give you a high level overview, not very deep dive. And the last, cloud networks. So cloud networks, as uh, we know, like leading provider, Microsoft, Azure, Google, AWS, they all are public cloud computing providers. So cloud is again something like you can understand this way. How a cloud network can be seen as a WAN with its infrastructure delivered by a cloud-based services. Some are allow function network capabilities, resources are hosted in public, a private cloud platform and made available on demand. So basically, cloud network is something. Let me take one quick example. Let's say you want to play a game, you want to install a game on your laptop or desktop, but the system requirement to install the game is like something that you should have a machine with a minimum of 8 core processors, not 8, maybe 32. Let me take big machine, 32 core processors, maybe 256 gig of RAM, 4 TB SSD drive. So generally, laptops or desktops or home computers like come with maybe 16 gig of RAM or 32 gig of RAM. Generally, right? Not like so much power. So nowadays, in fact, if you want a computer just for the testing or running a game, or maybe you want to test a software because of any reason, right? So instead of buying a computer with this like spec, in fact, what you can do, you can sign up to any public cloud computing provider. I mean, like you can create an account in maybe in AWS or Microsoft Azure or Google Cloud, and you can spin up a computer with this specification, right? And if you are running the computer for maybe a couple of hours, so you will pay rent for 2 hours only. So very nominal, maybe one or maybe two, 1 or 2 USD, right? Not more than that, right? Or even like initial 30 days or maybe 1 year, absolutely free even. A lot of resources are absolutely free. So here, what's happening, in fact, AWS or Microsoft or Google, they have a data center, a big data center. They have deployed like hardware appliances, devices there, like the servers, computers, networking, storage, and they're providing these services on rent basis, on actual usage basis over the internet. So cloud is something like on demand delivery of IT services, computers, infrastructure, right? Infra, database server, more than 200 services are there, and they are accessible via internet. You need to have internet, a good internet connection only. So basically, again, this cloud network is again like a kind of wide area network, because if AWS has one of the data center in US, or maybe in India itself, but not everywhere. In India, in one city only, right? And I'm sitting maybe a different location. And if I have spinned up a computer, a server machine in AWS network, and AWS network is in US or maybe in a different country, I'm sitting here. So again, it's like something a wide area network. I'm accessing resources over the internet, right? But why it is termed different, like a cloud network? Because in cloud, like there are a lot of benefits. There is just quickly, if I take one example, so I believe you would be able to connect with me. For example, let's say you are running a business and you want to run a e-commerce website or portal, right? You want to build your own website and you want to sell products, right? Online e-commerce website. And what you did, like you hosted your application on a machine, on a server. Your application is hosted here and is connected via internet. Users uh, from like different countries, different parts of the world, they're accessing your web server, right? HTTPS or HTTP colon, and then address. And then here again, and this server might be in maybe your physical premises, maybe at your home, in your office network, or even you can put your server in someone else's network, a data center. That is also possible, right? You can lease out space in someone else's network, a data center. We use a term co-location, known as co-location, right? Okay, now let's say your business is growing every day, and now you have millions of users, means like connections are hitting onto this server. Maybe you are running a campaign, a sale, in fact, let's say 25th December is approaching and you are running something like maybe Black Friday or 25th December or something, and a lot of traffic, a lot of requests hitting your web server. So obviously this would impact the performance, right? Your server response would get slowed down because a lot of customers are accessing your website. So the solution is what? Increasing number of servers, right? Increasing number of servers means like horizontal scaling. So you need to scale out server. You want to definitely you would then put another server here so that load can be distributed. Maybe another server, right? So just purchasing or buying 3 more servers, hosting the same website, and then using some load balancer. Load balancer is another device, in fact. And for what purpose? To distribute client requests across these 4 servers. Requests are hitting on this device, and this device is doing intelligent traffic management, right? Client 1 request directed to server 1, server 2, server 3, server 4. So number of requests like getting distributed or load balance across 4 servers. Now let's say sell period has gone now. This is off season, right? So definitely you would not be interested in running all these 4 servers because you'll have to pay for electricity charges, other charges, power backup. So you will have to bring take them down. I mean, like you'll like power off 1 or 2 servers. You are doing everything manually. You have invested money, in fact. But in cloud, and now let us take example of a cloud. Let's say you have your website, but your website is not hosted on your own server. You have hosted your applications in AWS cloud, someone else network in the cloud that is 24/7 available via the internet. You started with only 1 server. It's okay. There's only 1 server, right? You, let's say you were not able to predict the number of requests or connections. You initially thought, okay, let's say start with a single server. I'm not sure like how many customer would hit to my server. Later on, gradually or slowly, customers, yes, increasing, maybe a peak time, sale period, too many requests, right? So in cloud, we can, well in advance, like we can create a policy known as auto scale policy. So what happens with auto scale policy? With the increase of number of requests, number of servers will also get increased automatically. You don't have to do anything, right? Automatically. Let's say too many requests. Now number of servers is equal to 2. More requests, 3 servers. More requests, 4 servers. Obviously, you can set a threshold limit that maximum not going beyond 10 servers. Then again, you create a policy to scale in, scale out, and scale in. That no like peak time, off season, no sale is going on, please bring down 1 or 2 servers because you want to minimize the bill. So it's very good huge case of cloud computing nowadays. That is what auto scaling. on-demand auto scaling, and not only on-demand auto scaling, you don't have to invest money upfront. You can start any business, right, with $0. I mean, like initially, you don't have to pay to the cloud computing provider. You will be asked to pay by the end of the month, and on the basis of actual uses, you don't have to purchase expensive hardware. Similarly, you want a database server, you want application server, you want some other like resources. You are like a software developer, you are doing coding, you want to test a software. So you don't have to prepare infra, right? Just sign up to the cloud computing provider with your credit card and other information, spin up resource, enable service, right? And on the basis of actual uses, you will be charged no upfront cost, right? Or there is auto scaling. There are a lot of security also in place. So that's about cloud computing. Just a high level overview. I mean, so I believe you understand about a bit about cloud computing as well. So any question, guys, so far, like at least understanding network, LAN, WAN, cloud network. So if any question, any doubt so far, so yes, like there's a window you can ask now. You can unmute yourself, you can ask, or you can put your question in the chat box. So yeah, I think you have done cloud practitioner, right?
Yes, I have done.
So I'm sure like you must be very much familiar with these like auto scaling and all that, right?
I'm familiar with auto scaling and the load balance. Yep.
Yeah. Okay. Great. Okay. So yes, like and it's just only a few like to name it. I mean, like load balancing, auto scaling, and all that. A lot of other features are there in the cloud. Like even you can host any application, database, and there are different ways to get those resources. I mean, like if you want like resources to be managed by the cloud computing provider, yes, they would fully manage your resources. If you want to manage yourself, that is also possible. Technically, we use the term infrastructure as a service. If resources are managed by the cloud computing provider, so that's what your platform as a service. So that's something very popular nowadays. So that is your cloud networks or cloud computing. So if you are all are good to with networking basics, I mean like the fundamentals, what is network, LAN, WAN. So I'm moving on from here to the next one, and quickly I want to talk about still we are covering up networking basics, but now I want to discuss about some network devices, right? So we are going to understand networking hardware like routers, switches, and just a high level overview. Because once I start your CCNA, Cisco Certified Networking Associate, so I'll explain in detail routers, switches, because 60 to 70% topics of CCNA are based on routers and switches only, right? So it's just the beginning, introduction, high level overview, just to be familiar with all the terms that I would be using throughout the training session. I want to make you all guys aware with these terminologies. That's it. Otherwise, routers, switches, firewalls, they're very, like time-taking concepts. So we need to understand them in detail, and we will understand. But for now, just introduction. So networking hardware. So as I mentioned, networking means like in general, if take this. Okay. So as we all understood now, like networking means like sharing resources. But the first requirement, I mean, like if there are, let's say there are 10 or 20 computers, right? And if you have been asked to do the networking of 10 to 15 computers, right? That, okay, here are total 15 computers, like some laptops, desktop, and just put them on the network, do the networking. So the first point here is what? First, requirement, rather, I would say, is like reachability. You will have to address this issue. Reachability, I mean like connectivity. So because if there are 10 to 15 computers, so they all need to be within the reach, they all need to be connected, right? So reachability is very, very important. So for reachability, I mean like connecting 10 to 15 computers means like there should be a centralized device that I'm going to explain, like a switch. Then here, like end devices are host devices, means your laptop, desktop, known as host devices. Host. Some people also use term end devices. Devices are endpoints. One of the same thing. Endpoints. Your tab, laptop, desktop, right? So first piece of hardware is what? Switch. And computers, they generally come with a network interface card already installed, already there on the motherboard, right? So this hardware is already very much inside the laptop or desktop, but you need a cable, right? So cable is needed just to do the like connectivity this way. Here are different ports of a switch. And I'm taking example of wired networking, wired, right? No access point is required here. So once like reachability, you have finished doing physical connectivity, they are very much connected with each other, not directly connected via this centralized device, a switch device. Then the next important point here is understanding protocol, right? Because there has to be some common rules or set of instructions so that they can communicate with each other, because maybe one computer, laptop, Dell, maybe another one, uh, uh, HP, or maybe another one is server, maybe this one is a desktop, a tab, mobile phone, or some other network wireless devices, maybe they all want to communicate with each other. Different hardware, different vendors, different process. So there has to be a common set of instructions or rules. So that also you need to understand, right, about protocols. Because just doing physical connectivity is not doing networking. It's just the first step. First step is doing physical connectivity. The next step is like uh, just facilitating communication to happen. I mean, like some set of instruction, common rule or protocol, in fact, understanding that. So in this section, mainly we are going to first talk about this portion, the first portion. In the next module, maybe probably tomorrow, not today, we will talk about like this, the second like software, basically component, protocol. So in this module, module 2, we are going to understand, we are going to look at different piece of hardwares, right? That would be needed for doing physical connectivity, like the switches, a switch, cable, network interface card, right? And in next module, we will understand protocol. Because even if I take a non-technical example, I'm sitting here in India, maybe you guys are in different region, in US region, right? In different time zone, I'm in IST, you all are in CST or maybe ET. We are communicating with each other, right? And how? Via internet. So internet is like, is what? A transport, a connectivity. So for connectivity, we have internet. So for connectivity, we have internet. And as a software, I have a Zoom software, a program I'm running. But another important point here is what? Even let us assume there is internet. You, me, and everyone is connected to the internet. There is a software also, a Zoom tool or maybe Skype. But if the language that I'm speaking is not understood by you guys, or what you are speaking is not understood by me, so communication would never happen, right? If you are speaking in your native language I'm speaking in my native language. Obviously, my native language is not English. I'm not native English speaker. So if I speak in my language, obviously can never be understood by you. If you speak in your language, I cannot understand. So communication would never happen. So it's not only about the reachability. It's not about the connectivity. Reachability is one aspect of networking. Reachability is one aspect, obviously. Reachability or connectivity is one aspect only. Another aspect is what? Common language, a set of instruction, a common language, right? And that's what protocol is in networking. So in networking, the same is protocol. So if I have a computer here, another computer, this machine is a, like, let's say Mac machine, and this is a Windows, different platform, different hardware. It's a Mac hardware, it's Intel based or AMD based processor, different vendor, different OS. And let's say they both are connected, physical connectivity is there. But if both guys are not speaking same language, right? If they both are not speaking same language, so no way, like there can never be IP or connectivity or reachability. I'm not using the term IP. I will be using later on. I just forget. So I'll explain this IP and other stuff later on. So in order to ensure that both machines sort of like exchange information with each other, connectivity, yes, very much important. Reachability, yes, they need to be connected. There has to be some communication media. There has to be some transport. But equally important is protocol, a software, a common language, same set of instruction, right? So both are equally important in networking. So if you want to set up a network of 5 to 10 computers, so reachability, doing physical connectivity is important, but equally important would be the protocol set of instruction. And protocol is what? A software, a language. A protocol means a program, right? And because of protocol, because of the language, a set of instructions, different vendors, since they all understand or they all follow same instructions, same rule, so very much they communicate with each other. Even if I have a Cisco device, another guy has like Juniper device, they can communicate, right? Provided they both should use common protocol, same protocol. So protocol means like a language, a set of instructions, rules, a software, a program, right? You can use any term. So let me quickly talk about first hardware. Today, obviously, I'm not going to start protocols because understanding protocols very, very important. So in next session, next class, we'll understand protocols, but hardware is very easy to understand. So you can easily understand even, and maybe you might be knowing all this. So networking hardware, also known as network equipment, or computer networking devices, are electronic devices which are required for communication and interaction between devices on a computer network. So let me go to the hardware itself. So first, network hardware is host device. So what is host device? Devices that are used by end users. A decade ago, we mostly used desktop computers, but nowadays we have laptops, we have smartphones, we have tabs, desktop computers also. They all are like host devices or end devices, one of the same thing. And the term frequently we use in networking is server or servers. So a server is a computer designed to process requests and deliver data to another computer over the internet or a local network. A well-known type of server, for example, is a web server or email server, database server. So server means like serving computers, clients, right? A powerful machine. Because if this is my web server, website is hosted, and like thousands of users are accessing the website hosted on this server. So the compute power, memory, disk, read-write operation, definitely should be very, very fast. So generally, we buy a dedicated hardware, right, for servers, right? So for servers, we purchase HP servers. They are basically computers. They are computers like the same motherboard, processor, memory, disk, but high compute power, right? Memory maybe 512 gig, 256 gig of RAM, drives definitely SSD drives, redundant power supplies, good cooling, in fact, facility, because they generally run 24/7, 365 days. So there has to be redundant power supply, because if one power supply goes down, so there has to be another one. Same goes with like the cooling also, proper fan, cooling, and other stuff. So generally, server means like uh, obviously a powerful computer, a powerful machine, right? And then hosting different applications. So if I have hosted a website, so my server would be referred as a web server. If I'm running a database application software, then database servers. If I'm hosting email solution, then email server. So there are different types of servers, application servers, web server, database servers, right? So point to understand here is like a high compute power memory. So they are definitely different than the desktop computers. Your desktop computers mean generally 16 gig of RAM, 8 gig of RAM, i3, i5, or i7 processors. Servers are generally they like different Intel processors, Xeon processors, and maybe 12 core or 16 core, and even physically a physical processor you'd find minimum two processors, right? So you'll find minimum two CPUs, physical CPUs with multiple cores, in fact, a very powerful machine. So that is your server, in fact. Third component is network interface card, NIC, also known as NIC, right? So to connect our computers and servers to a network, there has to be some network interface or a hardware. And we use NIC, a network interface card, for this. In laptop, tablets, and smartphones, you will find wireless NIC, right? Because we generally do not use wire. However, in laptops, there are two adapters. In laptops, you must have seen there are two adapters. One is like your wired for doing wired networking, and another one is wireless Wi-Fi adapter. So generally, laptops come with two different adapters. One for doing wired networking, connecting your laptop physically to the switch with the cable, and also for Wi-Fi networking, wireless networking. And workstations means the desktop computers, they come with only one adapter, that is wired adapter, not wireless. And this is like the adapter like inside your laptop or maybe a desktop. And this port, like the port, this port is basically known as registered jack number 45, RJ45, registered jack. So and this is the cable, in fact, UTP cable. So generally you must have seen like in laptop also this type of port, in fact, RJ45 port. So this port is generally used for doing wired networking, connecting a laptop with a switch. Another piece of hardware is cable. Obviously, for wired networking, cable, yes, is a transmission media to transfer data from one device to another. Nowadays, we also use a lot of wireless technologies where we use radios, antennas, and radio waves for communication. So if you are doing wireless networking, then yes, cables not required. But for wired networking, this type of media, cable, yes, is basically unshielded twisted pair cable. And there are different categories here. Generally, nowadays we use category 6. In past, we used to use category 5. And the difference is category 5 means like maximum data transfer rate 100 Mbps. Category 6 means maximum data transfer rate 1000 Mbps, that is 1 gig. So this is the cable, in fact, and the connector is this connector is basically the same RJ45 connector. So connector is used to connect your network interface card with the switches. Switches is a switch is a physical device that connects devices such as computers, printers in a network and allows them to talk by exchanging data packets. And what are packets? Now we'll understand later on about data packets and other stuff. And you must have seen like the device similar to this, right? It's a switch. And here in this switch total, you see 8 ports only total. But yes, and it's just a very small switch. It's not enterprise level switch. A small switch and mainly for the home network or a small office home office network. Enterprise switches are very big switches, large switches, Cisco switches, right? And I'll show you like how enterprise switches look and different ports, maybe 48 ports, 96 ports, and very robust. In fact, it's very small switch. In fact, and generally we get this type of switch in some like very economical, very cheap. So I believe in some around 15 to 20 USD even, like we can get like non-manageable switches. I mean, like from different vendors, can be expensive as well. Depends like what type of software it is running, like configurable or not. A lot of other things, but in general, like it's a simple local, or not local, rather I would say a small switch, home switch, are mainly used for small office, home office networking. And in this switch, if there are total 8 ports, means you can connect maximum 8 devices. So you can connect one laptop, maybe one desktop, computers or servers. So this way you do the networking, right? So this is the cable that goes, one end goes to your laptop or desktop NIC card, and one end inserted here inside this, right? And this is the cable, in fact. So that's the way how we do the physical connectivity of like devices. So it's very easy, and just inserting cable, one end here and other end to computer. And if you want you have 16 computers, so yes, you can buy a switch of 16 ports, 24 ports, 48 ports, right? Generally, they are in multiple of 8. So 8 ports, or maybe then 16 ports, like this, are 8, 16, 24, and so on. Nowadays, in fact. Okay, and the next device is, and routers and switches. Your CCNA training, mainly, most of the time, we are going to discuss about or talk about switches and routers in very detail, right? So we'll understand the whole routing concept and switching also. So switching and routing, both are really very, very important. It's just introduction, high level overview. A router is a networking device that forwards data packets between different computer networks in different networks, right? So routers, like generally, we use routers to connect different networks in different cities, different countries, or even different buildings even, right? So router means different networks. Routers can be small as something we use at home or at a small business, or as big as the routers that are used by internet providers like AT&T that handle a lot of traffic. So router can be small, like this is also a router, a Wi-Fi router. There are 3 antennas here. A wireless router, generally we find this type of router at our home. These are also routers, enterprise routers, Cisco routers, very big in size, also very expensive, right? So we use in the enterprise networks, service provider networks, a big routers. So routers like big to enterprise, very big. In fact, there are different options, in fact. And the last device that I would like to talk about is a firewall device, security device, right? Again, it's very similar to the router. Very much it performs the same task as router does, routing, but at the same time it provides security. So firewall. So the name itself suggests a fire and wall, right? So a firewall, a wall, in fact, between different networks. So if my computer is here and the network here, so putting a firewall in between, in the middle of communication stream is very much controlling the traffic, right? With this firewall, we can control the traffic. If we want that this computer should not be able to open or access facebook.com, yes, we can prevent that. We can create policy here. We can restrict that the user should not be able to open any social networking websites. We do that with the firewall. Even firewall also secure internet link, right? So let's say if there is a firewall and here is internet, and in firewall itself there is a small router built in here. So it very much it also does routing, in fact. And here is my computer. Now let's say I want to protect my internal users from different attacks, spywares, malware, right? Other attacks, ransomware attack, or other attacks. So yes, firewall can very much do that job. With the firewall, yes, we can protect our internal users. For example, if a user gets an email with some link with malicious code, right? And if user is not very intelligent, smart enough, right? He doesn't know about phishing attack and these different attacks, right? And if the user clicks on the link, so very much like without a firewall, if let me remove the firewall from here, that means very much this computer is controlled by the hacker, by the attacker, right? The computer has reached to the attacker network, in fact, or CNC, command and control center. But with the help of firewall, if we put a firewall right here in the middle of communication stream, so even this firewall can sense that the URL is suspicious, malicious, it has some malicious code, is a attacker link. So even if internal user clicks on any email link, so this firewall will stop reaching out to the attacker server from this user. Firewall will do that. Even if user is downloading a free software tool from internet, right? And a spyware is also coming in with the software, right? And exactly that happens, in fact, because nowadays nothing is free. If you get anything free over the internet, so you should be suspicious. Why? Like the provider is providing me so much information free of cost, like without asking for money, without asking for anything. So most of the things like what we get over the internet, if that is free, so definitely we should be suspicious, right? There can be some hidden agenda. So what happens? Unknowingly, we download a software, maybe a free tool, a free software from the internet, and unintentionally, unknowingly, a spyware also get downloaded that runs as a service on Windows platform. And whenever we make any transaction by using the credit card, PayPal account, or some other information, so maybe information can be leaked, right? And the person can do some, like malicious activity by using the information leaked from. So can we protect all this with the firewall? Yes, if we have a good firewall or next generation firewall like the Palo Alto, Checkpoint firewall, Fortinet firewall. So very much we can prevent spywares entering our network, right? So even if user is unaware, but firewall is aware, firewall knows that very well. Firewall understand along with the software, there is some unwanted program that is coming in, right? Unwanted program, immediately firewall will stop that download. User wouldn't be able to download the software. And even a pop-up message will come up that the software you were trying to download had like some unwanted program. That is why your download has been restricted. So this way we can provide very much security to our internal users, to our networks from spyware, from malware, from viruses, from different attacks, in fact. So nowadays, firewall is something like a mandatory, very much must have hardware appliance, in fact. So any enterprise network, a small networks, definitely there would be firewall, because firewall controls traffic flow between network segments, also provide secure internet access. Secure internet access. So firewall is another hardware appliance, another hardware device. There are different vendors, right? Palo Alto Networks, a big name. Checkpoint, another name, a very good firewall. Fortinet is the third big name. In fact, these three companies are very big. In fact, Cisco is also sell firewall devices, but Cisco is mainly in networking, a big name in networking. In security, the big name is like Palo Alto, a company, in fact, headquartered in US. Checkpoint, Israel-based company, but the headquarter is in US. And the third big name is Fortinet. Palo Alto Networks, Checkpoint, and Fortinet. These three are the leaders in firewalls, right? Cisco also is in firewall. Juniper is another vendor, and a lot of other vendors, but they're not leader in firewalls. But in networking, Cisco is the leader in networking products. So firewall is what? Is a security gateway device that controls traffic flow between different network segments. The most effective way to secure the internet link is to put a firewall system between the local network and the internet, right? I'll give you a lab demonstration any day, right? However, it's not very much part of your CCNA training curriculum. There are some dedicated trainings for firewalls, but yes, we'll talk definitely about security also in this training. Basically, CCNA is your, as I mentioned, like the first step in starting your network journey, security engineer, and then there are some specialized training programs. So really, if you want to be security engineers, firewall engineers, so there are some other like training programs for that, like Palo Alto, Checkpoint, Fortinet, and all that. You want to get into cyber security, then you can take another training like path, in fact. So there are different paths. I mean, CCNA is the first step and very much like mandatory for all these training programs. Learning paths, I mean, like either cyber security, network security, cloud security, wherever you want to get into, yes, you can take any learning path if you know like CCNA level of things very well. So CCNA is the first level. But however, I will show you like how like we restrict URLs traffic with the firewall. Even like most of the viruses that comes from the internet, either exe file, maybe encrypted PDF, or some batch file or SCR. There are certain file types that are like very dangerous. Like, so generally what we do, we create policy on the firewall and to restrict uploading and downloading of these file types, right? So if I create a policy on the firewall that internal users should not be able to download any exe file, right? Or maybe encrypted PDF. So yes, firewall is very much going to stop all this, right? Internal users, no, there's no way like they cannot download any exe file or PDF file. We can even like if they are playing smartly, I mean like if they think, okay, what I'm going to do, I'm going to rename the file. Let's say I have to send exe file or PDF to one of my friend as an email attachment, right? Or anyway, I mean like Dropbox or Google Drive, exe file, and I know like firewall has a policy to not allow exe file upload. And if I use another method, I mean like if I rename the file from exe to doc or txt, right? So that I can bypass the firewall, and then I will tell my friend that it's basically exe file to again a rename. I mean like rename doc to exe. But no way, like nowadays firewalls, no, you cannot bypass this way. Firewall understand like you have just renamed the extension, but actually the file is still exe file. So firewall understand the type, the content, what is written inside this, the pattern, attribute, and based on that, decision is taken. So, I mean, like nowadays, firewall is something like the essential component or network device of any enterprise network. Very much like nowadays organizations, yes, they have firewall. There are different options, different pricing model, but firewall is something that is a core part. And this is the last slide. So here you can see like there is a device. It's a network device. It's similar. It looks very similar to the router, right? It looks very similar to a router. It's a network device basically. It's also doing networking. Computer here, and then servers or internet or hackers. So very much like with the help of security rules and policy that we create on firewall, we control the traffic. So firewall is again a network device. So I have come to an end. So I'm not starting the next module. Obviously, that is something really very important, protocols. So let's sum up the discussion, and then I will take your questions if anyone would have any question to ask. So what we discussed today, we started with first like introduction about Cisco learning path, a different certification. In learning path, as I mentioned, like there are 4 levels: entry level, associate level, professional, and expert. So since entry level is not mandatory, level certification and training. So generally most of the guys, like most of the students, they start with directly from associate level. We also starting from here only, CCNA, right? Some basic knowledge, yes, required, and that's why I started with the basics beginning. Some part of entry level already I'm covering here in CCNA. So basically the topic that we covered today very much was from this entry level, in fact, right? Not exactly I have started off like CCNA. And then we discuss about different networking concepts like the LAN and WAN mainly, and a bit of cloud networks. ISP networks, we didn't talk much about ISP networks. And then the third segment, we discuss about network hardwares mainly, right? And in hardwares, just a high level overview of routers, switches, network interface card, cable, and firewalls. So different network hardwares. In next class, and the very important topic, that is protocol. So we'll try to understand protocol, right, in networking, in computer network. What are different protocols? What is a protocol? So this would be in the next session. So any question, guys, so far? If you have any question, any doubt, then yes, go ahead. You can ask your question. And tomorrow also I'm available for the class. So we would have a class tomorrow as well. And same time. And another important, not important, just information that the meeting ID and password will be same throughout your like training session. So use the same meeting ID and password to join upcoming classes, right? So no different ID and password, same like meeting ID and password for all upcoming classes. So good so far, or any question, any doubt? Anything related with the training or the content that I covered today? However, it was just very basic. So probably like you must have heard like these names before, also like routers, switches, cables, and all that. So I just started very basic.
That's good. I don't have any question.
Okay.
Thank you.
Rashid or anyone else? Like,
no doubt and no concerns at all. You did really great. Things were very clear, very exciting. Couple hours of good attention. So I normally on the internet classes you get bored quickly, but you really kept us up busy and engaged. question is there materials, some things that we can read offsite, prepare ourselves for your next classes, or at least review it for the previous classes? Some things that we need to take, or is there some quizzes, things you know give us in the future? If you can cover those, would be really nice.
Yes, like since it was just like networking basics, very fundamental. So for this, yes, what I can do, I can share this presentation file, the file that I use, PPT file, in fact. So just for your reference, so you can those like PPTs you can use for the reference. And but in upcoming session, definitely I will share some resources for like because very much like we discussed today about networking in general, not very much like I have started CCNA. So as I mentioned, it was uh, like very much from the entry level training, in fact, like the basic foundation, like just to do you know like some foundation level. I'm like, because I understand like straight away if I start CCNA straight away without discussing some basics or entry level or foundation level or practitioner level like modules, so would be very difficult to cope up with, to understand. So that is why I started from very basic, very beginning. So probably not very good material you will find for this networking basics, because a lot of like topics are there in networking basics, but all those topics are not important. But I will try to like narrow it down. I will try to make some content for your reference for this network basic also. Otherwise, yes, in upcoming classes, once like I start CCNA, then I will keep on sharing some resources for study purposes for your reference, maybe reading in advance before joining the class, so that you can easily cope up with the content that I would be teaching here in the class. So yes, like in upcoming classes, I will share. And also once I start your lab session, then I will also give you, like some lab exercises. I mean, like tasks, I think, rather I would say, and you can perform those lab exercises tasks in the simulator, very similar to this, a Cisco packet tracer. So you can connect devices, you can do your lab kind of stuff, and I'll give you the guideline, like objective, the way how you can set up task also. So yes, rest assured, like wherever would be required, definitely I'll share like resources. For initial 2 or 3 sessions, like it's just networking basics. So what I will do, I will share my presentation files, the PPTs that I use today's session, maybe tomorrow's session. So let tomorrow's session be finished. Then I will share all together like these 3 or 4 PPTs first, like for networking basics. And then from next week, we would start CCNA properly. Then I will keep on sharing like resources for reading purpose, right? And even you also like once meeting is session is ended, so this like the recording session, yes, like I think 2 of you like are already recording the session. So once meeting is ended, then this recorded session will get converted into MP4. So you can use that as well, like as a good reference. You can watch like anytime. So if you want to just go through all the contents that I covered, so even it's on the best way, I mean, like just review this recorded session. And on safer side, I'm also recording at my end, so that if something happens, like your file get corrupted or something, then at least a backup copy would be with me. So I would share you, like in case if there is any issue with the recorded videos. So yes, I will share like some resources, PDFs, some other materials once like started CCNA. But today was just like some basics, and tomorrow also some basic part. I mean, like protocols in general, uh, we will understand. All right.
Got it.
All right.
As far
Yeah.
as the sharing, as far as the sharing goes, should we share with you our emails or our WhatsApp numbers, or how would you be able to share and what do you need from us?
Generally, since your class timing is something here in India is approximately 10:30 p.m. late evening. So I'm taking a session from my home. I'm not in my office. I'm not in my issue. Generally, a course coordinator, counselor takes care of everything like the batch management, scheduling batch and everything. But since your batch is late night batch, so I'll be managing all this. In fact, so what I will do, I will create a WhatsApp group and uh, or maybe you can create a WhatsApp group. You can add me in the WhatsApp group, and that would be the best way of sharing some information with each other. I mean, about the class schedule, or if class is getting delayed, maybe by 5 minutes or 10 minutes, or if I'm online, I'm waiting for you guys. So yes, that would be the best way for sharing information with each other. So otherwise, else the course coordinator, like the counselor in my training institute, she generally do everything. I mean, like she manages everything, the batch and every step. But since your batch is something running very late night, so I'm not taking your class from my office, from my institute. I'm taking your class from my home network. So I'll be like managing everything. So rest assured, I like, or maybe why I forget the name. Yahay, right?
Yes.
Am I pronouncing correct?
Yeah, you
so,
are.
Okay. So, like you can do that. I mean, like if you can create just a WhatsApp group for this and add if or maybe you can share like their numbers to me. Otherwise, just add everyone in the same WhatsApp group. I will name that CCNA group, right? And
yeah, I think that would be a great idea, and I think I can easily do that. So we'll get that clear right away.
Yeah, and done that. Yes, very quick. CCNA. Okay. So group is created. Okay. So yeah, this would be great then. Yeah. We can use this group like for sharing information, like maybe sharing some PDF notes or class schedule, right? So we can use this group for further communication. Okay. So that's all for today's session then. Anything else like you'd like to, anyone would like to ask? No. Okay, great. All right, so I'm just wrapping up today's session here. I'm ending the meeting, and tomorrow, same time. I believe you are all in same CST zone, right? I thought of you all are in EST zone. So CST is something like, I believe, 11 hours, 30 minutes. India is ahead.
Not EST. We are not in EST. We are in Central Standard Time.
Okay. You all are in Central Time then. Okay. All right. Earlier, I thought of like you all are in ET. Okay, no problem. So because there is an hour difference, I think, between both CST and ET. Yeah. All right. So no problem. So tomorrow, your time would be then, I believe, 9 a.m. tomorrow, right?
Right.
Yep.
Your time, CST zone. All right. And mine will be 8:30 a.m. then. Okay, because I'm in IST zone. So my time would be 8:30 a.m. So tomorrow, we'll connect. Your time would be 9 a.m. CST, and same meeting ID and password, right?
Yep.
Okay.
And then, me and Abdul Rashid and Muhammad, we've been talking about the schedule time, and we may, and we can, and talk. Me and Abdul Rashid and Muhammad will talk about the schedule. We can reschedule to a different time, and once we have decided the time that and convenient for all of us, we will let you know, and then we may kind of like, then reschedule. I mean, change the schedule or time, like, and
Okay.
to
Mhm.
evening instead of morning. We may, change it to evening or night, and then which is for you, it's in the morning.
Yeah. So yes, like just do let me know, like whatever time you decide, do let me know. I will check my timetable. I will check my other class schedules. And in this month only, in fact, uh, my time, I mean, like in December, uh, IST time, I mean, like 9 a.m. till 11 a.m. I'm like not free, in fact, but only in this month. Probably from next month, like yes, in morning also I would be available. In this month also I'm available in morning time, but either before 9 a.m. or maybe after 11 a.m. is my time, in fact, IST time. So just do a discussion about the time. Do let me know like what time suits all of you. I will check my time, in fact, uh, and if possible, then definitely we would keep that time, no problem. And I'm also very flexible. It's not like very rigid. We can mutually decide about the class timings. Maybe in because see generally we like teach in a group of 10 to 15 students in a batch generally, and personally I don't teach CCNA, in fact. So just because of like a reference and all that, so I've started. Otherwise generally I teach CCNP, CCIE, firewall, clouds, and some other trainings. But other teachers also, like when they take classes, so generally there are 10 to 15 students, but most of them are from the same time zone, same country, in fact. But your batch is a custom batch, in fact, a specialized batch. So we are not going to put any other student in your batch. Only you all would be in the batch, in fact, no other students, no other candidates. And that's good, in fact, because then we can mutually adjust the timing that suits all of us, in fact. Maybe in probably in any week, let's say you all are not available in early morning or maybe in the evening, so yes, even we can maybe cancel one class, we can reschedule, we can change the time. So definitely we would have all these benefits, because if the batch is very much dedicated, customized for you guys, so yes, that is very much manageable. We can manage class timing. We can even in case if let's say you all are busy or maybe occupied somewhere, not able to spare out time for the class. So even we can cancel or postpone any class, no problem whatsoever. And that's the real benefit, in fact, in of this. It's very much like one-to-one training. I mean, like if since you all are friend and in the same time zone, so it's very much like one-to-one. For me, it's one-to-one training, right? So no problem. Yes, we can do that, right? So time can be, yes, managed. It's all about like availability and mutual understanding, in fact. So and group, already you have created a group, so that's the best way to communicate with each other. So we can like even use that group to convey like messages, information, the class timing. Maybe let's say if I'm like stuck any day, I'm not able to take your class any specific day. So even I would very much in advance, I would inform you that I'm stuck today. So sorry, I'm not able to take your class today. Even you can do the same as well. So no problem, right? It's all mutually like can be done, can be adjusted. So timing, yes, just discuss with each other. And once like you have reached to any final time, then do let me know. I will check my time, in fact, my availability, and possible, then definitely I would do that. I would change the time, no problem, right?
All right. All right. Sounds good.
Oh, okay.
Thank you.
All right. So, yeah.
How would I be able to access the recording I've done? I've already stopped the recording. Where should I go?
Okay. Okay. So once like I will end the session from here. So then on your screen itself, you'll see like videos is getting converted. So this recorded video will get converted into MP4. Will take probably next 8 to 10 minutes. So the moment I stop this session, I mean like end this Zoom session, So on your laptop itself, on the desktop, I mean, like on the screen itself, you'll be notified that your videos is getting converted. Yes. So once meeting is ended, then you'll get your recording.
Thank you.
Okay. All right.
All right. Have a good one.
All right. Okay. Thank you.